Hi, my name is Dr. Mona Salami from Ajman University, UAE. My research interest was always about sustainability and how to make architecture help in mitigating the climate change. I'm happy today to present my research, which is about courtyard design as a sustainable tool for classrooms lighting and thermal performance. The main research aim is to minimize energy consumption for cooling and lighting and have satisfactory environmental financial impacts. A well-designed courtyard, which can be included into school buildings in the United Arab Emirates. The research motivations related to mitigate the climate change and decrease the CO2 levels and create healthier cities. Besides decreasing the energy consumption in buildings, mainly schools, for cooling and lighting. And finally, to design a sustainably green schools with the proper courtyard ratios. In the introduction, I will start talking about the UAE. In UAE, building residential public service and other types of building consume around 70% of the energy. The energy capacity in UAE is around 24.9 gigawatts, most of it consumed by buildings. In UAE, a huge amount of energy from fossil fuel is required for cooling the buildings with amount about 170 to 140 kilowatt hour meter square per year because of the harsh, hot, arid weather. Thus, the ecological footprint in UAE is more than 10 hectares, and that exceeds a lot the world per person footprint, which is 2.1 hectares. As a response to the world request to reduce CO2 emissions, UAE set a target to produce about 24% of the needed energy from green sources by the year 2021 to mitigate the climate change. UAE targets related mainly to the production of renewable energy, which is expensive in cost compared to the passive design concepts in buildings, which are supposed to be cheaper solutions and can decrease the energy consumptions by buildings with less coast. Traditional passive design solutions such as courtyards and badger were dominant in the UAE architecture to keep comfortable indoor environments in the hot climate. But unfortunately, these solutions were ignored after discovery of oil and usage of chillers. Schools are the main concern for my study. And why is that? Because schools in UAE are designed in a way that increases solar gain for the internal spaces with a huge elevations full of glass and that require a lot of energy for cooling and lighting. Besides that, schools as part of the built environment consume a lot of energy to provide comfortable conditions for students that must meet high standards for education, such as adequate lighting, appropriate thermal levels, especially in the hot weather of UAE. Schools consume more than 100 kilowatt meter square year according to school size and number of students, while in Greece, for instance, it's only 57 kilowatt meter square per year, as it has Mediterranean climate. The public school buildings in UAE consume around 18.5% from the education budget, which was around 16.43% of the total budget of the country on the year 2010. The schools and other public buildings, particular, became targets with significant potential to reduce the energy consumption. Courtyard can be effective solution. Adapting traditional passive design solution like courtyards in the school buildings can improve the thermal properties and lighting with less cost. In the literature review, I will start talking about the courtyard timeline. In general, courtyard is a surrounded area in a construction which is expected to exposed to the sky despite the type of the areas and surroundings. The traditional courtyard was a simple response to the environment and social requirements to provide a shield from the outer forces. In the present time, the courtyard used as a design concept, and there is increasing awareness about the power of courtyard in handling the environment forces. In the future, the courtyard is expected to be more highlighting ways to increase its efficiency. It is expected to have the potential to decrease the energy consumption for many types of buildings. Courtyard configurations are having many types like entirely closed or semi-closed or semi-opened, according to the type of the building, type of the plot, and type of the weather. Courtyard ratios. The geometry and ratios of the courtyard beside the sun location and the adjacent walls around it define the courtyard shaded areas, lighting effect, solar gain, thermal performance, and ventilation. Positive effect of the courtyard strategy on the school building can include environmental effects, which reduce the energy consumption and reduce the CO2 generation, and economic effects to reduce the initial capital cost for equipment of the chillers and reduce the running cost of electricity of the chillers. Finally, we will have from the courtyard social effects to improve the student satisfaction about the school building and improve the educational achievement. Courtyard and thermal comfort. The courtyard is superior in minimizing the cooling energy and supporting ventilation of the building in hot areas, but the average air temperature inside the courtyard differ according to the courtyard configuration and orientation. The courtyard can increase the natural lighting of the classroom. Natural lighting affects the visual comfort, productivity, efficiency, and enthusiasm of the occupants. In the schools, the reduction of the penetrated natural lighting into the classrooms causes increasing in the expected operative periods of artificial lighting. Selection of the research methodology. The research followed a qualitative method with comparative analysis for the case study, which was a school building with different courtyards ratios in Sharjah, UAE. To simulate the case study, virtual environment software IES was used to investigate the school buildings, enclosed courtyard environmental performance, and classrooms lighting. According to Crowell, the IES program actually and rationally simulate the environmental performance of building in a very good way. Case study features and climate. The case study for the research was Al Muruj English School, which is situated in Sharjah, UAE. All the UAE's emirates, including Sharjah, have a mostly arid hot climate desert with a high curve for the average dry and wet pulp temperature. Case study simulation characteristics and scenarios. The study compared two suggested scenarios of the school building with the closed courtyards in two different properties to the thermal efficiency and lighting of original school building with semi-open courtyard, the basic case study. The closed courtyards were created in accordance with Koch Nelson 2013 recommendation, who claimed that the thermal characteristics of the courtyard and its surrounding are clearly influenced by the size and height of the courtyard. According to Koch Nelson, the ideal width of the courtyard is between x and 3x if the altitude of the courtyard side walls is x. The research employed the 2x and 3x instances proportions for the courtyard and ignored the 1x proportion because it will provide a tiny courtyard that is better suited for homes rather than public building. And here it's clear the three cases for simulation of the project. With the first case, a basic case with open courtyard, and the first suggested scenario, which is 2x courtyard, where x is the height, and the second suggestion, which is the third case here, where we will have with 3x compared to the x, which is the height. Discussion and results. Illuminance analysis. The illuminance analysis for the investigation room was conducted on September 21st. The analysis in the simulation included the daylight factor, glare, and the lux. Simulation showed that the higher daylight and lux levels were in the open courtyard case and in the three courtyard case, as in table 3. This is the open courtyard, and this is the 3x courtyard. And that was expected as those cases have less shaded areas outside the investigation room and more sun exposure than the 2x courtyard, as what was shown in the previous thermal analysis. Because the investigation room in a classroom and it is better to avoid the glare in the classroom, analysis indicated that the least glare was in the 2x courtyard case with threshold 2012 48 CD meter square and with significant difference from the other two cases. And here you can see the difference between the 2x courtyard threshold in the for the glare in the test room for the case 2x and 3x, and open or no courtyard, which is the basic case. Sun exposure, min and max air temperature. The investigation room exposure to the sun varied in each of the three scenarios when the school building was involved. According to the sun route around the school, the investigation room north external will receive the most of the sun effects. 2x courtyard school had the least amount of the sun exposure for the investigation room, while the open X courtyard had the most. Therefore, the north wall of the investigation room had the least solar exposure. In the case of the 2x courtyard, the investigation room will be less heated, making the interior of the investigation room colder compared to the other two situations. The simulation showed that the 2x courtyard schools had the lowest min-max air temperature in the investigation room, and that was significantly different from both the schools with open courtyard and the one with 3x courtyard. Thus, the 2x courtyard has the lowest energy need for cooling of the investigation room. You can see here the open X, the sun exposure, it's for 3 hours, and the 3x courtyard, 2.5 hours, 2x, it's only 1 hour. The level of exposure of the sunlight affected the min air temperature in January and the max air temperature in August, where it's clear that the 2x were the best case for minimum and maximum air temperature through January till around all the year going to August. Temperature and air pressure inside the investigation room by using natural ventilation. Microflow CFD and computational fluid dynamics CFD in the IAS software was used to check the temperature of the air in the investigation room and related pressure contour inside it. Table 4 showed the temperature and pressure contour inside the investigation room, and the results were as the following. The least temperature for the investigation room was the case of 2x courtyard on 27th of April, the simulation date, and it was around 23.47 Celsius, which means less energy for cooling. On the other hand, the least pressure on the surfaces was in the case of the 2x courtyard in simulation date, the maximum reading around 0.277 PS. When the temperature is low, the pressure on the surface is low, and that proved that this investigation room has the least temperature when the pressure inside it is the least, when it depends on natural ventilation, though the temperature is the least in the case of TX courtyard comparing with the other two cases. Finally, I'm coming to the conclusion. Courtyards are an important passive design solution for the sustainable building, including schools. Finding of this study supported the hypothesis that the ratios of a cross courtyard has an impact on the building's thermal performance. The result of this study revealed that the maximum temperature at 2x courtyard has a width to height ratio that approximately 4 to 6 Celsius lower than the 3x and open X courtyards. Additionally, the simulation revealed that the open courtyard and the 3x courtyard examples had the highest daylight and lux levels, which was to be expected given that both cases features fewer sheltered outside spaces with a greater solar exposure than the 2x courtyard. At roughly 212.48 CD meter square, 2x had the best threshold glare level out of the three, which represented a substantial improvement over the other two. By this, at the end, I want to tell you by this, I found in my study that with this simple study in the future we can implement deeper studies about the courtyard ratios, proportion, orientation, which can help in decreasing the temperature of the buildings, and that can help in decreasing the energy needed for cooling and for using more electricity, and that will help to mitigate the climate change. Thank you so much. I'm happy to hear your question.